So in this video, I'm going to go over the week 14 practice. So first of all, the first question says find the equation of a line that is parallel to y equals 5x plus 7 and passes through the point 4, 3. So what we have to do first is pull the slope, and hopefully you remember when we have the equation y equals mx plus b, m is our slope, so that would be our slope. So m is equal to 5, and then we're going to label the through the point the x and the y, and then we're going to put them back in that equation y equals mx plus b. We're going to solve for b, and we're going to put our m back in. Okay, so when we do that, we have that 3, that's our y, equals 5 times 4 plus our b. So that's going to be 3 is equal to 20 plus our b. So we are going to subtract 20 from both sides. So negative 20 plus 3 is going to be negative 17. So b is equal to negative 17. So now what we're looking at is our b and our m. And we're going to put those back in the equation to write the equation. So y is equal to 5, that's our slope, x, minus 17. So that is the equation that's parallel to the line 5x plus 7 and passes through the point 4, 3. The next one says write in the equation line that's perpendicular. So what we need to do with this equation first is put it in y equals format so we can pull m. Okay, so I'm going to rewrite this equation, negative x plus y equals 5. I'm going to add x to both sides. So it's going to be y is equal to x plus 5. So remember, if there's nothing in front of the x, it's actually a 1, right? So now we know that m is equal to 1, so our perpendicular slope is going to be the negative reciprocal of that. So that means that our perpendicular m, let me write it this way, our perpendicular m is equal to negative 1. Okay? So now we're going to again label our x and our y. That's the point that we're going through. So we're going to put that back in our equation, y equals mx plus b. So that means it's going to be negative 5. Let's do it in a different color. Negative 5 equals negative 1 times 2 plus our b. So that's going to be negative 5 equals negative 2 plus b. So we're going to add 2 to both sides. So b is going to be equal to negative 3. This time we're going to again plug back in our new m, our perpendicular m, and our new b. So y is going to be equal to negative x minus 3. The next one says, what's the perimeter of a triangle? Well, first of all, you need to know what perimeter means. Perimeter means the distance around the outside of an object. So what we're going to do is we're going to use our Pythagorean's theorem to find the length of each of these sides. So I'm going to find this side right here first, this slanted side. It's falling from left to right, so I definitely know that it's going to be a negative slope, but what we're going to do is just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 10 down, right? And then it's over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 again, 10 down and 10 wide. So if we want to find that length, the blue length, we're going to do negative 10 squared plus 10 squared. That's going to be what? 100 plus 100. And that's going to be 200. And remember, we're going to take the square root of that value to get what the length is. Okay, so when we do that, that's going to be equal to approximately 14.14. Okay, now let's keep going and do another side. So let's do this side now. Let's do it in a different color, actually. So we're going to do this side now. And we're going to count 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so once again, we're going to do 5 squared plus 5 squared. That's going to be equal to 25 plus 25. So that's going to be 50. And again, we're going to take the square root of that. And so that value is going to be 7.07. Now we're going to do one more side, this side up here, because remember, we're looking for the length of all the sides so that we can add all three together. So we're going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we're going to do a 15 squared, and 1, 2, 3, 4, 5 tall, right? Plus our 5 squared. So that's going to be 225 plus 25. So that's going to be 250. And again, we're going to take the square root of that. So the square root of 250 is 15.81, approximately, right? So now what we need to do is we need to add these three values together, because that's going to give us our perimeter, okay? So when we add those three values together, we get 37.02 is the perimeter of that triangle. So again, what we're finding is the length of each of the sides using Pythagorean's theorem, because remember, each of these was a right triangle that we created here, okay? And because of that, we can use Pythagorean's theorem to solve for the side opposite the right angle. It says, what is the perimeter of the following polynomial? Okay, so this time I'm going to find the perimeter of each side. So what I want to do first is I'm going to look at the one that's easiest to see, which is yx right here. So that's 1, 2, 3, 4. So yx equals 4. Then I'm going to find zy. Okay, so we're going to find zy right here, and we're going to do it the same way we did the in the previous problem. So we're going to look at our up and over, right? So we're going to go up 3 and 1 over. So when we're looking for zy, hopefully you can see over here, this is also 3 up and 1 over, right? So those are going to be equal, okay? So what we're going to do first is we're going to find that 3 squared plus 1 squared. That's equal to 9 plus 1, that's 10. So that's going to be the square root of 10 there, okay? Which is approximately 3.16, okay? Now, we already talked about this. Wx is the same, right? Isn't it also 3.16? It is, because the side lengths are the same. So then our last one is going to be zv and wv, okay? So zv, we're going 3 up and 3 over. And this one over here is also 3 up and 3 over, if you can see it. So zy is going to be 3 squared plus 3 squared. So that's going to be 9 plus 9. 9, I was about to jump. So that's going to be 18, and that's going to be the square root of 18. So when we take the square root of 18, that's approximately 4.24. And again, you should see that WVW or WV, however you want to say it, is also 4.24. So once again, what we're going to do is we're going to add all these sides together. So we're going to add 3.16 plus 3.16 plus, and actually we started with the 4. The 4.24 plus the 4.24. Again, perimeter means the distance around the outside of an object. Okay, so when we add all those together, we get 18.8 units. All right, number 5 says, determine if the point 24 lies inside, outside, or on the circle whose center is, remember this is our h and this is our k, and the radius is 3. So this is our r. So we're going to write the equation of this circle first. Okay, so that's going to be x minus 5 squared plus y plus 1, and that's because it's minus a minus 1 squared, and then we're going to do the r squared, which is 3 squared, which is 9, okay? Now it's asking us where does this point lie, so what we're going to do is we're going to take this point and we're going to make it our x and our y, okay? Actually, let's make those a different color, x and y. So we're going to put that 2 right there. We're going to put that 4 right there. So 2 minus 5 is negative 3 squared plus 4 plus 1 is 5 squared. Well, I can already tell that's not going to be equal, right? Because that's 9 right there plus 25. So let's keep going. So this is going to be 34. So how does 34 relate to the 9? It's not less than, it's greater than. It's greater than 9, right? So it's asking us, does the point lie on, inside or outside the circle, right? So this is going to be outside the circle, right? Because it's bigger. 34 is greater than 9, okay? Then it says, what is the center and radius of the equation of the circle here? So we're going to group these. So we're going to put all our x's in one set of parentheses. We're going to put all our y's in another set of parentheses. We're going to move our constant to the other side, okay? So I'm going to do x squared plus 6x plus our blank. And we're going to do y squared plus our 4y plus our blank. Now we're going to subtract this 10 from both sides. That's going to give us negative 9 over here. Okay? So now we're going to take our middle term and divide it by 2. So we're going to take this 6 and divide it by 2. That gives me 3. And then we're going to drop that right down here in our parentheses for our binomial squared. Then we're also going to square that term, and we're going to put it back up in the blank. Okay, so 3 squared is 9, so we're doing a 9 there, and we're doing a plus a 9 here. Okay, so whatever we add on to the left, don't forget we have to add to the right. Okay, so now we're going to do the same thing with our middle term over here. So we're going to do 4 divided by 2, which is 2. So this is going to be y plus 2 squared again. And now we're going to square that term once again. 2 squared is equal to 4. So we're going to put the 4 there. We're going to add the 4 up here on this other side. So notice the 9's cancel each other out, the negative 9 and the positive 9. So this is going to be equal to 4. So then it asks us, what is the center and the radius, okay? So here, remember, we're going to pull these values the opposite of what's there. So our center is going to be negative 3 comma negative 2, and our radius is going to be the square root of whatever's on the other side of that equal sign. So we're going to do the square root of 4, so that's going to be 2. All right, number 7 says, given the parallelogram ABCD has the following vertices, A, B, C, what would the coordinates of point D be? Okay, so let's go ahead and plot these. So 1, negative 3 is where our A is. Then we've got B is at 1, 0. So that's going to be right there. Then we've got C is at 4, 2. And then they're asking us what is D. Okay, so what we want to do here, it says it's a parallelogram. Okay, because it's a parallelogram, we know the opposite sides are congruent and parallel. So what I want to do is I'm going to look at this right here. It's 3 down. Y'all see that? 3 down. So from point C, point D should be 3 down, right? So we're going to count 1, 2, 3 down right there. So those sides look parallel and congruent, right? Whoops, I did that wrong. I did 4. Now they look parallel and congruent. That's what I think is point D right there. So let's double check it with the other slope. So going from B to C, we're going to go up 1 and over 3, right? So here, we're going to go up 1 over 1, 2, no, sorry, up 2. 1, 2, and over 3. I can't count today, guys. Up 2 and over 1, 2, 3. So, yep, there we go. So our points are going to be the same, no matter which side we use for the slope. So this point D is going to be 4, comma, negative 1. And that's point B right there. All right, so the next one says, what is the most specific name for the quadrilateral LMNO? So what we want to do here is we want to compare opposite sides. Okay, so let's look at LO. For LO, we're going up 1, 2, 3, 4, and over 2. So up 4 over 2, that means the slope is 2. So let's check this opposite side. If we go from M to N, we're going over 2 and up 4 again. So that's going to be, again, 4 over 2. That's going to be 2. That's going to be equal to our slope. So the slopes of these two sides are the same. And we also know that the sides are congruent because 2 squared plus 4 squared equals 2 squared plus 4 squared, right? This is going to be 2 and this is 4. Okay, so they're also congruent. Now we're going to check the other pair of sides. So here again, we're going to count 1, 2, 3, 4, 5, 6 over and 1 down, right? So that's going to be a negative 1. So the slope here is going to be negative 1 over 6. And the line is falling from left to right, so that looks correct. Again, going down 1 here and over 1, 2, 3, 4, 5, 6. Okay, so the slope here again is negative 1 over 6. So here again, opposite sides are parallel. And we know these sides are also congruent because, again, negative 1 squared plus 6 squared is equal to negative 1 squared plus 6 squared. So if both sides are parallel and congruent, then this is a parallelogram. And we can say that because LO is parallel to MN and LO is equal to MN. And then our opposite sides are LM is parallel to ON and LM is equal to ON. Again, if sides are both opposite, both pairs of opposite sides are both congruent and parallel, then it's got to be a parallelogram. So it says for number 9, Kyle's trying to determine if triangle ABC is a right triangle. What is the best explanation for his conclusion? Well, it looks to me like if it is a right triangle, the angle at A and the angle at C are acute angles, and B might be our right angle. So let's check and see if it is. Okay, so here we're going down 1, 2, 3, 4, 5, 6. So that's a -6, and over 1, 2, 3, 4, 5, 6, 7. So that means our slope here of AB is equal to -6 over 7. So that means if BC is a right angle to it, should be 7/6, right? Okay, so let's check and see if it is. So here we're going 1, 2, 3, 4 to the right, and 1, 2, 3, 4 up. So 4 to the right, 4 up. So the slope of BC is 4 over 4, which is equal to 1. So because these are not negative reciprocals of each other, this is not a right triangle. Looks like it's a right triangle, but it's not, and that's why we have to check it. So it says for letter A, use the slope formula to prove that AB and BC are perpendicular, therefore the angle. Nope, that's not true. Use the distance formula. I don't want to use the distance formula because that doesn't really help us at all. We need the slopes, okay? And then use the distance formula again. No. And then the last one says use the slope formula to prove that AB and BC are perpendicular, therefore angle ABC is not a right triangle. That is our correct answer right there.